Okay, today's topic of discussion is graph coloring. Graph coloring. Easy one. The same concept of backtracking is being used here. This is also one of the problem under backtracking, which will be solved under backtracking. So we will be given with the graph G, and we have to color with minimum number of colors. Okay. And m be a positive integer. Let G be a graph and n be a positive integer. So let's consider a graph G, and let m be a positive integer. Let it be a positive integer. M denotes the number of colors required to color this graph. Now, what's graph coloring problem? Graph coloring is to discover whether the nodes of the graph should be colored in such a way that no two adjacent nodes should have the same color and only m colors should be used. Okay, here m is a positive number and it is called as a chromatic number. We call this m as chromatic number. So you should use minimum number of colors and try to color the graph. It is a m colorability decision problem. It is also called as m colorability because we are using m colors. Hence we call this as m colorability decision problem. Okay. So it is m colorability decision problem. So how to decide the number of colors which are required to color a given graph? That is, if d is the degree of the given graph, then you can color it with d plus 1 colors. If d is the degree of what do you mean by degree of the graph? D is the degree of graph. What is the degree of graph? Yes, degree of graph. Degree of graph is nothing but the highest degree of a particular vertex, isn't it? If you have a graph like this, A, B, E, C, D, E, and we have this graph in this way. Now, what is the degree of each graph? Let's consider this graph. So what is the degree of this graph? This is a graph G. What is the degree of it? It is equal to the degree of the vertex. Highest degree of the vertex is nothing but the degree of the graph. So if you take this, if you observe this graph, what is the highest degree of any particular vertex here? It is 3, isn't it? We are checking. So 3 is the degree of this graph. Okay. So maximum we may take 3 plus 1 colors, d plus 1 color. Okay. If d is the degree of the given graph, then it can be colored with d plus 1 colors. You can use at most 4 colors. Less than this is also fine. So what the number of colors which are used to color this graph is called as a chromatic number. So you can color this. If we choose 3 colors, can we just color this graph? We'll check 1, 2, 3 different colors. Adjacent should not have the same color. Then we can again color with 1 because adjacent. Now we can take 3 or 2 for this. Okay, 3 or 2. So that the vertices will not be adjacent. See here each, see 3 is surrounded by 1, 1. E is surrounded by 2 and D. So here the continuous adjacent vertices should not have the same color. That's the idea here. Adjacent vertices should not have the same color. And you can choose colors in such a way that you will use minimum number of colors and maximum you can have 3 plus 1 degree of the graph plus 1 colors. Okay. So M colorability optimization problem. So D plus 1 max you can have. So M colorability optimization problem will ask the smallest integer m, will ask the smallest integer m for which the graph can be colored. For which the graph can be colored. So m is a chromatic number here. So we are discussing the M color graph coloring problem, wherein we'll be given with a graph and we have to select how many colors we can use in order to color this graph, and that M should be smallest integer for which the color can be for which the graph can be colored. And if D is the degree of the graph, maximum you can have D plus 1 colors which are being used. Optimization means smallest integer m for which the graph can be colored. Here if you will take, we can use 4 colors because the degree of the graph is 3 here. We can use 4 colors, but with 3 only we can color this graph. So this is M colorability optimization problem, where this is optimization problem which asks for small integer of m for which the color can be graphed. 3 is the smallest integer for which this color can be graphed. Graph can be colored, sorry. Okay, so with this, let's move on to coloring the graph. Let's take a small graph and try to color it. Okay. So let's consider the small graph. This is usually the problem graph which we will be using for understanding first. If you will understand, then you can always do with the bigger graphs. So we have a small graph A, B, C, D. Okay, this is our graph. And so D, what is the degree of this graph? Degree of this graph is 2. So I have 3 colors being used, and those 3 colors I'll take it as 1, 2, 3. Okay. So we'll construct a state space tree and then we will check how different nodes can be colored. Okay. Okay, let's start with by constructing a state space tree. As you all know, we should start with a null node. In the first level, we will check what are the colors which can be given to A, and in second level, what are the different colors which can be given to A, B, C in the third level, D in the fourth level. Okay, so let's start. So we are starting in the first level with giving color 1 to A. If A is colored with 1, if A is colored with 1, so this refers to the color of A. So we will move on to next level now, B. So if A is colored with 1, what are the possible colors for B? So B can be colored with either 2 or with 3, isn't it? So if A is colored with 1, B can be either colored with 2 or 3. Check here. It can be either colored with 2 or 3, either of these colors. If B is colored with 2, then what is the possible option for C? Okay, so when B is Sorry, 2. Okay, when B is colored with 2, we have to check what are the possible colors which can be used on this C, right? Okay, when we are checking with C now, look into the graph and you should tell me. See, now this is 1, this is 2, check here, this is 1, A is 1 and B is 2. Then we can have two colors, either of the colors for C, isn't it? So it can have 1 or 3, right? 1 or 3. Now, let's move on further and check. If A is 1, B is colored with 2, C with 1, then what are the possible colors which can be used for D? Which are the possible colors which can be used for D? We will check. D. For D, what are the possible colors we can use? When it is 1, when C is 1 and A is also 1. So what is the possible colors we can choose for D? It can be 2 and 3, isn't it? Okay, now we will backtrack again. We all got this. We started with A. We colored A with 1. Then we moved down to B. So B can be colored with either 2 or 3. So we took that option, 2 or 3. Then we moved down to C, to color C. If A is 1 colored with 1 and B is colored with 2, so what are the possible colors for C? You are left with 1 and you can color with either 1 or 3, isn't it? But not 2, because if you color with 2 again, it will violate the rule of graph coloring, where adjacent nodes should not have the same color. But it can be colored with either 1 or 3. Okay, when it is colored with 1, so A is 1, B is 2 and C is 1. So what is the possible color for D? D can be colored with either 2 or 3, isn't it? See here what happens if we will take this path. It will be 1, 2, 1, 2. Yes, we can color like this, isn't it? Node to adjacent node should have the same color. So this is one possibility, 1, 2, 1, 2. Or else we can also have 1, 2, 1, 3. 1, 2, 1, 3. So possible colors for D can be 2 or 3. That is what we have shown here. Right. Now again we will move back and check. What if C is colored with 3? When C is colored with 3, what happens? What are the possible colors for? Okay, now when C is colored with 3, if we give the color as 3 here, yes. In that case, what is the possible color for D? Can someone tell? 1, 2, 1. So what is the possible color for 3? Sorry, for D. For D, what is the possible color? And how many colors are possible in this case? What is the possible color for D? Can I have 1 here?
No,
Can
ma'am.
I color D with 1? No, because adjacent nodes will have same color. What about this? Can I color it with 3?
No, ma'am.
Adjacent colors will be same. So I have only one option, that is to color with 2. Got it now? Only to color with 2. That is the only option available. In case if we will choose 3 here. In case if we will choose 1 for C, then we can either color D with 2 or 3. But if you take 3, then the only color which is possible to use for D will be 2. Clear? Likewise, we should move on with all the possible combinations. Okay. Did you all get this much? Have you all understood this much?
Yes, ma'am.
Okay. Now we'll move on to finding what if B is colored with 3. Okay, when B is colored with 3, what are the different possibilities of coloring C and D? Let's check with that. By looking into this path only, you can easily identify and tell. Okay, 1 we are trying with B 3. B is 3. Okay, now when A is 1 and B is 3, what are the possible colors we can have for C? Can we have both the colors? Yes, of course. 1 and 2. Okay. Now, when A is 1, 3 is 1 and C is 1, I can use two colors. If you will see here, I can use either 2 or 3 for D. Isn't it? 1, 3, 1 means I can either use 2 or 3. Backtrack. 1, 3, 2. In this case, see here 1, 3, 2. So which is the only possible color for D now? It's only 3, isn't it? So that I will note down here. Did you get this much? Hope you have understood this, how coloring is going on. Right? If
Yes,
A
ma'am.
is 1, B is 3, then the possible color for C will be either 1 or 2. If it is 1, these are the two possible colors for D. And if it is 2, then this is the only possibility for D. Right? Likewise, we will move on to the next option, that is coloring A with 2 and checking. Now we colored A with 1. We colored A with 1 and this was the option for coloring. What if we color B with 2? Sorry, A with 2. Color 2. If we will start with 2. Now we are starting with 2 for A. Now what are the possibilities? So what possible colors B can have? We can color B with either 1 or 3, isn't it? Either 1 or 3. Now, when B is colored with 1, what are the possible colors for C? So B, I am coloring it with 1. So the possible colors for C can be either 2 or 3, isn't it? Check here. What are the possible colors C can take now? It cannot take 1, but it can take 2 and 3. The possible colors are 2 and 3 here. Got it? Now, what if C is colored with 2? What are the options for D? I can have 1 and 3 here. If you will just look into the graph, you can easily identify. Yes, I can have 1 or 3 here. When C is 2. What if C becomes 3? So what is the option I have here in this case? What is the only option
1,
available?
ma'am.
Only 1. So I should note down here. I have only 1. That's how it goes on like that. Can you try further? Will you try it? For this level I do. For 3 you will do it. Okay now? Okay. For 3 let's do it. Yes. When it is 3. Okay. Yes. Possible colors for C. What could be the possible colors for C? I can color it with either 1 or 2, isn't it? But I cannot use 3. 1, either 1 or 2. I cannot use 3 because it becomes adjacent. Now, when C is, yes, can you tell me here which is the which is the possible color for D? If it is 1.
3.
Yes, only possible color is 3. That's it. If it is 2 on the other hand, if it is 2, then I can use which two colors here for D?
3 and 1.
Yes, right. So 1 and 3. Okay, that's all. Over. Now you have to do it for the third. When A is colored with 3, what are the possible colors for others? Three now. A we have taken 3. Can you do this? This part will you do and share me the screenshot?
Yes, ma'am.
Yes, all of you try doing this. What are the possible colors when A is colored with 3? Yeah, there are 50 in the meeting. Let me see how many will send. I'm here and I'm waiting for your answers. Yes, right. Rachita has sent. Shweta also finished. It's right. That's all. That's it about your graph coloring problem. Easy, isn't it?
Yes, ma'am.
Yeah. Okay. Uh, another 10 minutes. I have second hour also for some other class. So we'll wind up at 9:45. So if you will complete this, isn't it? So you have an algorithm with that. The algorithm goes like this. You keep trying. I'll just write down the algorithm. So we have the algorithm M coloring. So in exam, if you are asked to write the algorithm, you will have to write. Okay. Just solving the problem will not give you full marks. You have to write the algorithm also if it is asked. So this is done by using recursive backtracking algorithm. Okay. And you will have a graph which is represented by using the adjacency matrix. and you will have K, which is the index of the next color. Index of next vertex to color. Okay, so what we do is we will just repeat this process. So we'll generate all legal assignments for K, where K is the index of this next index of the next vertex which needs to be colored. Then we will have one function called next value. So this will assign to a particular vertex a legal color. To check which color should be assigned to that particular vertex, we have this next value of K. And in case that function, this function returns 0, then we have to return, which means that no new color is possible. No new color is possible in that case. If on the other hand, if K equal to n, then we can print it. At most, m colors have been used to color n vertices, and we can write all those. What are the colors which are used? Else, we have to just color the graph again with the, we'll pass the next vertex to find which color should be used to color that particular vertex. So we'll perform this operation. Just if K equal to 0, if x of K equal to 0, then no new colors are possible. On the other hand, if it is equal to 1, then all colors have been used and we have to just write everything. Otherwise, we have to give one color and check whether particular vertex can be colored. So in next value, we have two algorithms here, isn't it? We have used next value. This is also one of the algorithm. So what do we do in that next value? In this, we check if all colors are used. Okay. If all colors are used, we have to return 0, isn't it? If K is equal to 0, then no new colors possible. So it has to return x of K equal to 0 here, if all colors are used. Otherwise, it has to check 1 to n. What? Check if color is distinct from. Here what it does, it has to check whether adjacent vertices are having distinct colors. If g of K comma j is not equal to 0 and x of K, this is checking for whether adjacent vertices have the same color. In that case, we will have to break it. If adjacent vertices have same color, we will have to break it. Otherwise, if j is equal to n plus 1, then we have to return, which means that when j becomes n plus 1, it means that there are no new colors. So you have to just return it. So this says no new color found. Okay, it says that new color is found. So this will be repeated until you find another color. Okay, this is algorithm associated with colors, graph coloring problem. So, and this is how we will color the graph. So to complete this, we can say that if B is colored with either 1 or 2, in that case, C can be colored with either 2 or 3. In case it is colored with 2, the only option available is 1. Obvious, 3, if you have all 3, 3, 1, 2 means it will be left out with only 1. Here, you will have 2 options. 3, 1. So you can either color with 2 or 1. Okay, so it is either 1 or 2. Looking into this, once you are familiar, you can just write it down. So if 3, 2 means you can either color with 1 or 2. Here 3, 2, 1, you are left out with only 1, that is 2. Here 3, 2, this is 3 actually, sorry, this is 3. In that case, you can have 1 and 2 colors for C. If you will check here, you can easily make out. See, if something is repeating, then you will have 2 options. If it is not repeating, then you will have only 1 option. See here, 1, 3, 1. 1 is repeated, so you have 2 options here. 1, 3, 2. All 3 are done. So you are left out with only 1 color. Easily you can just do it. Okay. Any doubts with M coloring?
No, ma'am.
Okay, it's quite easy.